Now we want to talk about solutions of trigonometry. Now this is the trickiest part when it comes to trigonometry solving for theta, solving for angles. Usually when you punch your calculator and you get an answer, you feel satisfied with what you've got and you feel compelled to just write that one only on your answer sheet. But now, because you're now in grade 11, you marked grade 12 or 11, you now need to get used to writing the solutions. Whenever you solve an equation involving cos, for instance, if your answer came from finding cos inverse, so you need to now know the general solutions. And these are not given to you, so you need to go into the exam actually knowing them. So if you solve an equation involving cos, normally if you want to find theta, theta would now need to be plus or minus the primary value that you get from your calculator. Then it's plus 360, and then k, where k is an element of integers. What do I mean by this? Suppose say I'm given an equation and it gives me cos theta is equal to half. Now if I take my calculator and I find my theta, theta is equal to cos inverse of half. Now because I used cos, this is going to give me 60. Now normally if I was in grade 10, this answer would be 100% correct. But now because you are in grade 12, you are not going to write this as your answer. You are going to first of all write the general solution. The general solution then becomes plus or minus 60, because 60 is what you're going to get on your calculator when you press cos inverse of half. So it's going to be plus or minus 60. 60 is now your primary value, and then you're going to say plus 360 k, where k is an element of integers, like that. And you must not forget to write where k is an element of integers. Similarly, if I do the same thing for sine, suppose say they give me sine theta is also equal to half. I'm just using half because it's easy. I know I'm going to solve it. Sine theta is going to be sine inverse of half. So which means that I'm now going to press my calculator and I'll get theta is going to be equal to. Now, for whenever I solve the equation for sine, I am going to get theta is equal to, the answer I get from my calculator will be 30 in this case. That 30 will be 360k plus 360k. But there's a reason why I put it up there and I put another branch there. So what you now need to do is to take this 30, subtract it from 180, so it will be 180 subtract the 30 to get the other value which is supplementary to that one, which is 150, and that also forms part of your answer. So now this is called a secondary value. The 150 is called a secondary value, and k is an element of integers. So you see, for sine it's a bit complicated because sine will form sort of like a branch. And once sine forms sort of like a branch, you know that it is like that. So basically this is called a general solution. Now let's look at the last aspect, which is the general solution for tan. The general solution, if I am given tan theta is equal to 1, for instance, which means theta is equal to tan inverse of 1. Now tan inverse of 1 would give me an answer for theta which is equal to 45. Now with this one, this is the primary value that I get from my calculator, but because it's tan, I am going to say plus 180. You are not going to use 360, you are going to use 180 plus 180k, where k is an element of integers. And that, ladies and gentlemen, those are the three general solutions of trigs for tan, for cos, and for tan. And whenever you are solving something, you first of all write your answer in general solution form. Then from there you can then try to write the particular solution, and we'll talk about that when we are now looking at questions to say from the general solution you must learn to write your answers in particular solution. And particular solutions are very simple. All you simply do is you punch them into your calculator and they'll tell you which values to choose from. Okay, now let's look at the first case, and I think we've already looked at the first case when it comes to solving trigonometrical equations. This is quite a long aspect of this because it's just solving of trigonometry. Then there is case A. Case A is the one that you looked at when you were in grade 10. In grade 10, you solved trigonometrical equations, the simple ones, like the ones we're just doing. So let's say I'm solving a simple one, and it's going to be 5 sine theta is equal to 3. Now, which means that I know that sine theta is going to be 3 over 5. And then this means that I've got sine theta, so my theta is going to be sine inverse of 3 over 5. And this is going to give me sine inverse of 3 over 5 on my calculator. Just press my calculator, second function, sine inverse, and then my fraction is 3 over 5, like that. And then I'm going to get 36,86. So this is 36,87. Now this is theta, my primary value. It's not my answer. My answer is going to be theta is going to be equal to, because it is sine, it is going to branch out 36,87 plus 360k, where k is an element of integers. Then I'm going to subtract that from 180, subtract 180 there, and then also it's also going to be related to 143,13 plus 360k. Now I've got the complete general solution for that case. Now that is case 1, where you are just solving and it's simple. Let's now look at case 2. Case 2, which is case B. Now in case B, we have got both sine and cos in the equation. So for instance, they'll say sine theta, 3 sine theta is equal to 6 cos theta. Notice how they've got, there's no plus or minus sign in this equation. Sometimes they can write it in a different format. Let me just show you the different format somewhere here. So it's going to be 3 sine theta minus 6 cos theta equal to 0. This is the same question, but somehow, sometimes when you are looking at it in an exam, you're under pressure, you won't see it's the same question. So what you need to do is to now look at sine and cos and come up with the tan ratio. So the cos comes this side, so that I've got sine theta over cos theta is equal to the 6 there. The 3 goes to the other side, is 3. So I now have tan theta is equal to 2. Do you see that? So I'm now using tan to solve this equation. So if I'm using tan to solve this equation, I'm going to also get the general solution for tan. So second function, tan inverse of 2. And then that is going to give me 63. So theta, in this case, is going to be, remember, theta is equal to tan inverse of 2. So theta in this case is going to be 63,43 plus 180k, where k is an element of integers. Please do not forget to write k is an element of integers. Now let's go to the next case. I'm trying to move a bit fast because the video must not be too long. Case C. Now in case C, this one employs factorization, and it's very common. And normally you can tell that there is factorization involved because there will be a minus sign in between, and you or somehow you can't solve it by either the first situation where it's just simple and straightforward, or you can't solve it using tan. But you can see that you can actually factorize. I'm just going to give you an example. Sine theta, right, is equal to 2 sine theta cos theta. Now if you look at this case here, I can see that on both sides, but obviously I can't use the cos one, because if I divide by cos everything, I'm going to get tan on this side, tan on this side, and it's going to be pretty messy. So the easiest solution I'm going to do is take it to one side. So this is going to be minus 2 sine theta cos theta. And as you can see, I can easily factorize the sine there. Can you see? There's sine there. So the sine comes out there. Sine theta, bracket. If I remove sine from there, I divide that one. It's going to leave 1. And then this is 2 cos theta. This is obviously going to be equal to 0 there, because I moved them to one side, isn't it? And then obviously it's going to be also equal to 0 there. Do you see that? Now what does this mean? It means that the sine theta is equal to 0, and also 1 minus 2 cos theta is equal to 0. So which means cos theta is equal to negative 1 over 2. And that's I let me just do it in slow motion so some of you can see what I'm doing. Let me just work backwards. Don't want to move too fast. So let's not move too fast. So we're going to say 1. Then this one will go to the other side there. So this is going to be equal to 2 cos theta. Can you see that? Now this means the 2 will come this side. This 2 will come there. So if the 2 comes there, it's going to be 1 over 2 is equal to cos theta. So the sine, because it was alone, it is going to be equal to 0. Now it means that here I need to write a general solution for the sine, and I need to write a general solution for cos. So I know my sine. Let's start with the sine. Sine theta is equal to 0. So if I've got sine theta is equal to 0, then theta is also equal to 0. Do you see that? If I find the sine inverse, it's sine inverse of 0, theta is equal to sine inverse of 0. Can you see that? And then sine inverse of 0 will give us theta is equal to 0. But because this is an answer for sine, it will have two answers, 0 and 180 minus 0 is 180. Then I'll have plus 360k and plus 360k, where k is an element of integers. Same thing for cos. Remember our cos is theta is equal to half, which means that theta is equal to cos inverse of half, which means that theta is equal to plus or minus 60, because remember for cos it's plus or minus, and it's plus 360k, where k is an element of integers. So that is how you solve the second case, the third case, sorry, case C. Now let's look at case D. Now case D is a bit more complicated. Now case D is when you have got sine on one side and cos on the other side, and they don't have coefficients. So I like this one because you can virtually do it without using a calculator. So they say sine theta is equal to cos 30 plus theta. Sine 2 theta, let's just put 2 theta there, is equal to cos 30 plus theta. Yes. So now in this case, you can see there's nothing in front of sine, there's nothing in front of cos, and they are not the same, so you can't divide. You need to turn one of them into the other. So the sign must be changed. So the only way you can change the sine to the cos to become a cos is by using 90 minus. So in this case, I am going to use this side because it is less complicated. I usually don't want to use the one with the plus because it can complicate my life. So I'm just going to change that one. So sine theta is the same as cos. Can you see I put cos instead of sine? The minute I put 90 minus, I take this one, minus 2 theta. Then I have got the same thing. This one and this one are the same. So this one and this one are the same. But but here I'm using my knowledge of reduction to write this in another form. So this is now cos. Can you see that now both of them on both sides are now in terms of cos? So which means that I can now write one as a general solution of the other. So because it is in terms of cos, I'm going to say 90 minus 2 theta is equal to this one here. But now that one I must write plus or minus bracket 30 plus theta and then plus 360k, because it's now a general solution, so it's k, an element of integers. Do you see now I'm solving that? But now I did not use my calculator because I had to use the idea that this is cos and this is cos, therefore their angles must be equal, but one of the angles must form a general solution, and I picked the one on the right. So now I have to simplify that, and simplifying it, it's entirely up to you. Remember, you want this theta to come this side, and you need to work it out in the fastest way you can see possible. Okay, so now here the 2 theta remains where it is, and first of all let's take plus theta. So this will become minus theta, and you can keep working it out until you simplify it. Alright, let's go to the next case. The next case is case E. Now case E is one of the most common ones in the exam. If you come across case E, then you should be happy to see this case here. So it's usually a quadratic equation, and usually it's uniform. So I'm just going to make it uniform. So if they've got 8 sine theta squared plus sine theta minus 1 is equal to 0. This is a quadratic equation, and if you know how to solve your quadratic equation, you know that this is sine squared, this is just sine. So our A in this case is 8, our B is 1, and our C is equal to -1. So remember, we're not finding x, we're finding sine theta, because it's not a quadratic equation for x, it's a quadratic equation for sine theta. Sine theta is minus b plus or minus square root of b squared minus 4ac. And when we do quadratics, you're going to see how we press our calculator. And then obviously sine theta there, sine theta, if I substitute, it will be minus, my b is going to be 1 plus or minus, and then square root, our b is again 1 squared minus 4 bracket, our a is 8 and our c is minus 1 close bracket, divided by 2 and then 8. This will give us 2 answers. Now when it gives us 2 answers, it means those 2 answers will also give us the general solutions, which will give us 2 general solutions, 2 answers for sine theta, and the general solutions, there will be 2 general solutions. So let us just plunge that into our calculator. And then our A is 8, our B is 1, and our C is -1. And then obviously this is going to be, I'm just going to write it on the other side, sorry. Sine theta is equal to 0,297, and also sine theta is equal to minus 0,4 2. So if I find the sine inverse is there, I'll now get the general solutions for both answers. So it's second function sine inverse of 0,297, which means that I will get theta is going to be equal to, the first one is 17,28, and the other one is what? 162,72. This is plus 360k plus 360k, where k is an element of integers. And then the other one, theta is equal to, again we must do the other one also. And remember, this question will have about 7 marks, so you need to spend time on it. Second function sine inverse of negative 0.42, which is going to give us negative 24,23,83, and also there it's going to be (204,83) plus 360k plus 360k, and then k is an element of integers. So you must remember that you are going to have so many solutions. Now let's go to the last case so that you can the last case is a very nice case. Case F. Case F usually is about, it's the same as case E. The only difference is now they want you to apply your identities. So now, suppose say they say sine squared theta plus cos theta minus 1 is equal to 0. Now, if you look at this equation here, you will notice that it cannot be solved. Let's just put 8 there, like putting 8. If you look at this equation here, you will notice that it cannot be solved using the quadratic equation, because we've got sine squared there, but we've also got cos there. Now, we cannot use the quadratic very straightforward. So we need to first of all make it uniform there. We look at this one and we say this is the only one we can change. We cannot change the cos. We cannot change this cos here, but we can change this one. So how do we change this one? We use our identities. It's 1 minus cos squared theta plus cos theta minus 1 is equal to 0. Now, once you've got this, you've got 8 minus 8 cos squared theta plus cos theta minus 1. Now, once you've done that, you're now going to say 8 minus 1 is going to be minus 8 cos. Can I put 9 here? Plus 9. Let me just put a plus there, so that it can work out very well. So we're now going to say, okay, fine, that's 8 cos squared theta plus cos theta plus 9 is equal to 0. And then from there you can then solve the quadratic equation. We're not going to solve it because we've already solved one, but remember this one is now in terms of cos, so it will have a general solution for cos. Okay, so those are the different cases that you look at when you are solving trigonometrical questions.